Tēnā koutou katoa, ko Monique Cornish tuku ingoa. Welcome to my bunker here in Tamaki Makaurau. It's wonderful to have you joining us from across the motu today for the second in our climate action series. For those of you who were able to join us for our first session, we spent time talking about mitigation, what it is, and what our role as engineers is in moving us towards a 1.5 degree world. Today, we are going to shift our focus to adaptation. And this is incredibly timely as we move out of COP and into a period when, due to policy announcements, we'll see more focus shifting to adaptation. So we hope that you'll leave the session today prepared for those conversations and to integrate physical adaptation into your practice. A reminder that our third session coming up in 3 weeks' time will conclude the series and focus on transitional risk, the risk to our businesses, institutions, organisations and communities that are a result of both adapting to physical changes and transitioning our economy to one commensurate with a 1.5 degree world, or hopefully less. In the interim between our first conversation and today, there's not just been COP, which has been incredibly exciting for our community of practice, but there's been another very exciting announcement coming from Engineering New Zealand itself. And I'm really pleased to hand over to Richard Templar to share a little bit about ENZ's climate statement and some of the work that you'll see being presented through the new climate portal over the next couple of months. So Morena, Richard, thank you for joining us, and I'll hand to you.
Morena, everyone. Kia ora, tēnā koutou I aku whānau. Kua hu mai nei ki te korero I ngā kaupapa kai te akitanga. Ka nui te koa mo te koutou kāna kau ki te aro mai. Greetings to the family who have gathered here to discuss the topic of sustainability. Great is our happiness for your interest in attending, and thank you. So kia ora, I am Richard Templar, the Chief Executive of Te Ao Rangiho Engineering New Zealand. Last week, we were delighted to launch our climate change program, Engineering Climate Action. It will support conversations about climate change across the engineering profession. Taking on climate change is something we feel very strongly about and which members have been asking for some time. Engineering Climate Action will support you, our members, as well as the engineering community and government to take positive action to respond to climate change. We'll be providing resources to help you at Engineering Climate Action, or one word, .nz. So that's the place to go to get the latest and greatest information for you and the profession. And now it's my pleasure to hand back to Monique.
Thank you so much, Richard. Our collaboration between the Sustainability Society and Engineering New Zealand on this project and more broadly on the Engineering New Zealand climate action work is incredibly important, both to us as a technical interest group of Engineering New Zealand with a singular focus on sustainability and climate change. And I guess that work coming together today to share a bit more information on adaptation for our community of practice is a really good example of us as technical experts sharing what we know, but making sure that we contextualize it for practicing engineers. That is exactly what we hope to do today. Let me share our agenda. I'm just going to touch a little bit on our climate context, which is the same as what we discussed in more detail in our first session, but I'm conscious that not everyone is with us on the journey for all three sessions. So I'll just provide a little context and then hand over to my colleague, James Hughes, who's a Technical Director in Climate Risk and Adaptation at Jonkin & Taylor, who was one of the leaders of the team that developed the National Climate Change Risk Assessment, which was launched last year, although the work was a good year and a bit in the making. That's going to give us a picture of physical risk. I'll then hand over to Richard Ryan-Hamel, who's a director in the natural hazards practice at Tonkin and Taylor, who's worked extensively across the Motu, moving from risk to creating adaptive solutions. And that's really where we want the conversation to go today, as to what do we do as engineers about the risks that we're facing. We'll discuss both risk and adaptation and creating adaptive capacity through our work in the breakout sessions, as we've discussed. The kaupapa of these sessions is to make sure that what you don't get is just talking heads. We want to hear from you about what your questions are, what's working, what isn't, and help you create a real community of practice on the ground through your ENZ whānau, but also to welcome you into our whānau as climate change and sustainability practitioners. We will aim to wrap up bang on at 1:30, but of course, if we conclude a little earlier, we're happy to give you a few minutes in your day. So, a reminder of why we're here. Why are we calling for climate action? Why has Engineering New Zealand put forward the position statement calling for action? Essentially, no matter what we do, our world is going to look very different in even 2050 and certainly 2100 than it does today. As I've said, the conversation today, we're going to focus on how we get ready to adapt to hopefully not just survive, but thrive in that world. Our first conversation was about mitigating, about how we reduce the greenhouse gases in the atmosphere that are causing this change. Even if we do our absolute best and get those emissions down to 1.5, the physical effects of climate change will still be felt. They're being felt today, and they will continue to be felt. That's sea level rise, that's increased temperatures that will lead to changes in water availability and security, changed rainfall patterns, drought, and even potentially bushfire, which is one that we don't always think of in New Zealand straight up front. But this is all very real in terms of what we can expect by the end of the century. As I've said, today we focus on adaptation. In our practice, we've got to hold both mitigation and adaptation in our heads and do both. But today we'll make it a little easier for you and just focus on adaptation, how we understand risk and then choose to avoid it, manage it, transfer it, and ultimately have to live with some of that risk, and how our communities, our way of living, our way of doing business will begin to be different. In our last session, we spent quite a bit of time talking about the policy context and I guess the broader drivers for sustainability and climate action and some of the levers for that. We talked globally about things like the SDG and of course the Conference of Parties with COP26 just concluding this week. We also talked about how that information and those commitments are propagating down nationally and down to our individual businesses too, with many of our partner organisations on this call who've established 1.5 degree targets. The policy context, I think, is particularly important when it comes to adaptation. I'm going to hand over to James in a moment with what was really the te waihanga, the cornerstone of our national policy approach to adaptation, the National Climate Change Risk Assessment. From that, central government are developing a National Climate Change Adaptation Plan, which will be released for consultation in the new year. I'd encourage you all to read, review and comment on that. And some of you may have already been involved in the consultation that MFE have led on what national adaptation looks like. That being said, there is no excuse to wait on government or to think that government is going to have all of the solutions. Government can't and won't, because as we're going to hear today, adaptation is it's a physical thing and it's really place-based. What's important in a community in Dunedin is going to be different than what's important in a community in Hanna Springs. We all want to be safe. We all want to be able to bring up our kids and make a living, but some of those things are consistent no matter where you are in the world. but our place and space and what's important is different, and how each community is going to choose to avoid, manage, and ultimately live with risk is going to change too. So I encourage you not to wait for policy, but to know that that's one of the drivers that's coming. And I will hand over to James now to take us through both the work on the NCCRA, but as James talks, I really want you to start thinking about how do these risks that have been identified nationally play out in your place, where you live, where you work. With no more ado, I will hand over to you, James. Thank you for joining us today, and look forward to your insights.
Thanks, Monique. Kia ora tātou. Hopefully everyone can hear me okay. My name's James Hughes. I live in Tauranga and work for Tonkin & Taylor, and focus most of my time on climate risk and resilience type issues around the country. I'm going to set the scene a little bit around, as Monique mentioned, the physical risk context, and then pass over to Richard, who's going to talk about adaptation. But the areas I want to talk about today were just repeating a little bit and going into more detail around the context for physical risks. I'll then talk about the National Risk Assessment and some of the, I guess, the key findings, noting that it's a 280-page odd document. So I'll try and skim that as briefly as I can, and hopefully that'll be interesting to people. And then just finish up with some other salient points, I suppose, around physical risk that are emerging, that some of you will be aware of, but hopefully is interesting to others as well. Now, hopefully can I control the slides here? I'm not sure if I can.
Yeah, so just up the top of your screen, there's a green bar, view options. If you click that and then request control.
And I will give you control.
Sorry, guys. Request control.
And then if you just give that a couple seconds, that should kick in.
There you go.
Great, thanks very much. Okay, let's see if I can move.
So if you just click, that should change.
There we go. Oh gosh.
And now you can use your mouse, your keyboard, sorry. There we go.
Great. Okay, let's get into it. So look, I wanted to start with this slide here that most of you will be aware of, but the underpinning quote of this is, we must plan for a 4-degree world while aiming for a 1.5-degree world. The new report from the IPCC has been, instructional and I suppose emphatic in the language that they're using around climate risk, and using words like, it is now unequivocal that human influence has warmed the atmosphere, ocean and land, and other quotes such as, or findings if you like, that the global surface temperature will continue to increase until at least mid-century under all scenarios that they've modelled, and then global warming of 1.5 degrees and 2 degrees will be exceeded in this century unless deep reductions of CO2 and other greenhouse gases occur in coming decades. So really, I guess, pushing the language further towards the, there's no remaining uncertainty here. Monique showed this slide earlier, but I just want to sort of set the scene around the types of hazards that climate change brings and how we use those within a risk assessment. So most of you are aware of these: rising seas, warmer oceans, more flood events, changing weather around fires, more heat waves, etc., etc. Now, another hazard, which I'll just go into a bit of detail, and this is drawing from some work by NIWA, which I think is a really stark reminder of some of the coastal issues that we might face, and Richard will pick up on this, and that with a modest sea level rise of around 0.5 metre or slightly under, which will occur towards the middle of this century under most scenarios, possibly out towards 2060, that if you look at this 1 in 100 year line here, that with that modest level of sea level rise, a 1 in 100 year coastal inundation event could occur around about on an annual basis. So that's pushing a 1 in 100 year event to an annual event. And this is on average and does change by harbours around New Zealand. But this is, an indication of the quite staggering changes in some of the return periods we might expect at the coast. Now, when we think about climate risk we need to make a bunch of assumptions. And key to that is the assumption around the RCP scenario, or the representative concentration pathway, that we use to inform the degree of warming and therefore the climate drivers and hazards that we assess. Now, some of you will be aware of the RCP language has recently been replaced by SSPs in the new climate report I showed earlier. However, in a New Zealand context, we are, and the climate projections that the government and NIWA have produced, that we're still using this language around RCPs, and it's still appropriate to use it. So when we assess climate risk, we need to make a choice, if you like, around how conservative or which of these scenarios we want to use. And there are four main ones: 8.5, 6, 4.5, and 2.6. So 8.5 is the high end or high emission scenario. And that is generally used in all climate risk assessments as a high end scenario when we assess risk. So that's a tick, if you like, around one of the scenarios we use. In the National Risk Assessment, RCP 4.5 was the second scenario that was used, which represents a more ambitious level of, I suppose, of warming reduction, and represents sort of 1.7 to 3.2 degrees warming, as opposed to this higher end one. So the point being that we need to assume a level of one of the RCPs which relates to the degree of warming. The blue line at the bottom is representative of the bending of the curve we need to undertake if we're going to reduce emissions and limit warming to 1.5 or even 2 degrees. And that brings with it its own share of risks, including some physical risks, albeit at a lesser degree, but importantly, those transition risks which will arise as we rapidly decarbonize. So I just want to make that point really clearly, that the RCP scenarios are foundational to any assessment of climate risk. So moving now on to the NCCRA. Was New Zealand's first national assessment, and it provides a picture of how New Zealand may be affected by climate change related hazards. And as Monique mentioned, the government is currently developing a national adaptation plan. This diagram sets out that national adaptation plan process. The first risk assessment occurred and released last year. The national adaptation plan is to be published next year. And then if you follow this roadmap, there's a second national risk assessment in 2026. One thing to note is that MFE led the National Adaptation Plan and is leading the National Risk Assessment and is leading the National Adaptation Plan. That responsibility will fall to the Climate Commission to take that forward, to look at progress on that first National Adaptation Plan going forward as well. So there's subtle changes in responsibilities as we progress. Some of the headline risks from the National Risk Assessment, and this is a very brief, but I'll give you a picture of them, and then we'll focus a little bit on the built environment one. So the risk assessment itself was across 5 themes or 5 domains: the natural environment, the human economy, the built environment, and also a theme around governance related risks. The natural environment talks, some of the salient risks were around coastal indigenous ecosystems. The human domain focused a lot around, I would call them indirect risks, which relate to social cohesion and well-being, and exacerbating and creating new inequities in communities. And that's a really important consideration when we're thinking again about climate risk, is those the different vulnerabilities or inequities that might exist within communities that might make them more predisposed to climate-related hazards. Other human-related risks were around some of the cultural impacts, particularly around marae, wahitapu sites, leading into the ability to sort of practice in tikanga, or even gather traditional mahinga kai sources, etc. So a range of risks that were identified and explored in the human domain that cross-cut really across all these areas. The economy focused, I guess, at a high level, and as you can imagine, one of the challenges in a national level risk assessment, and this is something I guess we can explore later in the discussions, is we've got national assessments, we've got regional assessments, we've got local assessments, and even organizations are doing this. So these various levels that makes it quite difficult to, I guess, put boundaries around those different levels of specificity and granularity. And so in the economy and across all these domains, it was very much at a national level, looking at, for example, in this case, economic costs, financial system instability. So very high level implications for the economy. Built environment, and I'll speak more about that, but the salient ones were potable water supplies relating to drought, and obviously buildings and communities at risk from a range of hazards, including coastal inundation and flooding. And we'll talk more about that. And the governance ones, there were a range of risks, but the one that sort of stood out for me particularly was that we currently don't have institutional arrangements and legislation that is coordinated. And an example of that is our Building Act, which requires a 1 in 50-year level of protection from flooding, versus the Coastal Policy Statement, which requires you to take a 100-year view, versus local council infrastructure design codes that vary. Some take a 1 in 10-year view, 1 in 10-year ARI for pipe systems, and a 100-year view for overland flow paths. So a really disparate view, a really disparate set of guidelines and institutional and statutory and non-statutory guidelines that are not coordinated and not leading to consistent outcomes. So that was an interesting finding there. So I want to just briefly scan through some of these, and I won't read them all out to you, but if you can see the bold text, these are the 8 risks in the built environment. Potable water supplies, risks to buildings, risk to landfills and contaminated sites, risk to wastewater and stormwater systems, ports, transport networks, airports, and electricity infrastructure. And I'll talk a bit more in detail about some of those. What I'll draw your attention to is when we look at climate risk, typically you look at multiple time horizons. And one way to sort of pull out which ones of those might be more potentially a higher priority or more urgent is looking at those risks that are higher risk earlier in time. So in this example here, you've got risk to wastewater and stormwater, which is major, now moving to extreme, similar the buildings, major, extreme, and the same as the potable water supply. So you, as a decision maker, you might pick out those 3 from that list and say those ones are potentially more or a higher priority than some of the others. Just skimming through some of the findings in some of those key areas. So risk to potable water was one of the really, I guess, known, but isn't one that's probably talked about as much in a New Zealand context as opposed to some of the coastal issues we face. So we've got potable water affected by drought, heavy rain leading to contamination, salination due to groundwater rise, which is a really emerging problem around some coastal communities, and algal blooms as a result of combining the effect of drought, increased temperature, low flows in waterways, etc. Moving on to wastewater is another really interesting one. So this is going to a specific example, but this one is probably worth talking about. And some of the research we did around what's happened in countries like Australia, California, and particularly South Africa in really dry conditions is that droughts have led to obviously water restrictions being put in place. That has resulted in much lower flows in our wastewater systems because people are instructed and mandated to use less water. That it has in turn resulted in systems becoming blocked and a real spike in maintenance cost, particularly the example in California had that issue, and they even had trees, roots busting through pipes because they were so starved of water that trees were entering into those wastewater systems. The blockages that occurred because the flushing flows weren't occurring were causing, all sorts of issues around odor. And then you had more concentrated wastewater entering treatment plants that some of the processes weren't set up for that. Some of the, depending on the types of processes at the wastewater treatment plants, they didn't operate as well. And you had discharges of poorly treated wastewater to receiving environments that were already under stressed, and there was a range of toxic effects in receiving environments, algal blooms, etc. So it's a really good example how you can see these sort of knock-on cascading impacts through this one example of drought impacting on wastewater. Transport systems are going to be impacted. Some examples on this page: landslips were really familiar hazard in New Zealand and common occurrence. Rising sea levels, coastal flooding, the example there is in the Nelson area. And of course, in extreme temperature, we're going to see increased instances of flushing of asphalt surfaces and bitumen, leading to maintenance issues and issues of degradation of pavement. So those are just some examples of some of the climate-related issues to transport. And finally, around the electricity sector, and this is the Rangitata floods in 2019, where 9 pylons were disrupted, and there's some pretty significant outages in that area. So flood issues relating to the distribution of electricity, as well as bushfire issues, which are going to increase over time. From a generation perspective, there are issues as well. However, it was deemed to be less of a risk than to the distribution infrastructure, given that there's expected to be sort of a relative, the amount of storage that the hydro sector has got, and the changes in snowmelt weren't deemed to be of concern over the medium term, as opposed to the risk to the transmission and distribution networks. Moving on. Sorry, I'm just trying to change slide. It doesn't seem to. Here we go. So a couple more slides here just before I finish up, and this one really just speaks to some of the cascades and interdependencies, and I really like this diagram because it basically says that ecosystems, water resources, agriculture sector, cities in general, and particularly our approaches to managing disaster risk, and that's a really important one, that we need to bring together our approaches from disaster risk management and climate change adaptation increasingly together. So I was glad that when I found this diagram that it included that. But ultimately, at the bottom of this diagram is health and well-being, and all roads lead to health and well-being impacts to communities. So I think it's a helpful way to look at some of the interconnections, and it has most of them, but there are many that aren't shown there as well. Now, just before I finish, I'll just touch on some of the I guess other emerging areas around climate risk, and this diagram captures some of them that are probably helpful for people on this call to be aware of. Most of you may be aware of some of these. So on the right, obviously, is the National Risk Assessment. And I'll just add to that by saying a number of regional councils are now looking at regional climate change risk assessments, sort of building on the knowledge base that the National Risk Assessment developed. There's been a new guidance document that I'll also talk about in a second that has been published around undertaking local climate change risk assessments. That is a simplification, if you like, of the national methodology, and there's going to be some webinars coming out on that. This middle report came out, and this is related to the Zero Carbon Act reporting power. The Zero Carbon Act has a second part which allows the government to request from councils, government departments, and lifeline utilities to request their preparedness for adaptation and their management of climate risk. So this was the first report on that basis of a survey that went out, and it's worth looking at. But I guess the main point is that for those of you on the call who work in the local government sector or the lifeline sector, that this is going to be something that the government will probably begin to focus on more, around requesting of those organisations their processes and management of climate risks, and either through surveys or asking for evidence of that. Related to that is on the left-hand side, there's a new bill, a new act that's being passed. But New Zealand is the first country in the world to make the disclosure of climate-related financial risks mandatory for certain sectors, and those sectors include the investment community, banks, insurers, and listed issuers, or anyone listed on the stock exchange who's got listed equity or debt. So that captures a huge swathe of large business and in New Zealand, and is just making a really increased focus on climate risk. And there are some double ups, if you like, between particularly the lifelines community, who are captured under both the reporting power but also the mandatory disclosures. And the methodologies for doing those disclosures is being developed by the XRB at the moment, and it looks at physical risk and this sort of, I guess, emerging concept of transition risk. Now, just before I got 2 more slides. So this one here is really drawing on that idea of managing risk within an organization. This is a view of how that risk can propagate through a company or through a council or through an organization of any sort. So here you've got the climate hazards. They can lead to a range of physical and transition risks that sit possibly to its assets or operations directly, but also within its supply chain, logistics and market. But importantly, you've also got the macroeconomic factors that around legislation and carbon pricing and the broader, I guess, macro context that might create risk for an organization. These types of risks can flow through to a range of secondary risks, from liability and credit through to insurance, and ultimately all can have financial impacts on an organization. So yeah, it's a helpful way to think about how these risks can propagate. And my last slide before I finish is really just pointing everyone to this new guidance. If they're interested, there's some webinars coming up, and this is the guide to local climate risk assessments, and some key points, I guess, reflecting on what I've just spoken about around applying some of this thinking in practice, is taking a staged approach, being clear that you need to assess risk across multiple time horizons, making some really clear assumptions around those RCP scenarios and which ones you're going to look at, having themes or domains of risk really clearly set up front, considering risks and opportunities, as well as these concepts of direct and indirect and cascading risks as well. So I hope that was useful, and I'll finish there and pass over to Richard. Or back to Monique, actually. I'm not sure where we're going.
Tēnā koutou katoa, ko Richard Ryan Hamill tōku ingoa, the Sector Director for Natural Hazard Resilience and the Technical Director for Coastal Engineering for Tonkin and Taylor. Hopefully I have got control, I think, or request control. So we can move through these slides. Yep, that should be all good to go. So this part is the dynamic adaptive pathways planning and looking at that physical adaptation response. I'm going to be doing a little bit of a deep dive into the dynamic adaptive policy pathway, or DAP for short, through a series of tables and images, taking that back to a case study, which is that Clifton to Tangoyo coastal hazard strategy for 2120 a number of years ago. And then talk about some of the issues and challenges, and on how this could impact on designers and engineers who are dealing with these kind of issues. So in terms of the dynamic policy pathway, the images are sort of a bit like the metro line, sort of as a way of communicating and identifying what are actions and when are transitions. It's an approach that was developed in the Netherlands by Del Tares, and is embedded in the New Zealand coastal guidance, and it's based on particularly on coastal and riverine flooding settings. But I think what it recognises is we can't be certain of all of the changes that we face from climate change. And so there's deep uncertainty, and we need to keep options open for as long as possible while preparing for any particular outcome. So what the DAP process does is develop a series of actions over time, so the pathways, and it's based on the ideas of making decisions as conditions change and before obviously severe damage occurs, and as existing policies and decisions prove no longer fit for purpose. And to determine which physical pathway we should follow, there's a series of triggers of when to change. And at this point, we need to take and consider additional or different actions and alternative pathways to avoid reaching a threshold at which damage can occur. this tool, by identifying the actions and understanding of triggers and changes over time, means that we can explore and communicate different pathways and test the consequences. And it's an effective communication and policy development and action development tool that involves all stakeholders that have a say in management. So if I can just take us through to this little metro map on the right-hand side, what we can see here on the vertical axis is the current situation of where we are now, 4 possible actions, A to D, going from red to blue, and along the x-axis, we've got timescales of 2 different climate change scenarios, a low end and a high end kind of scenario, and the years when those might occur. One of the things with these scenarios, particularly for triggers, because the time basis is uncertain, depending on which pathway, you can also put that in terms of incremental increase of sea level rise, for example, or rainfall intensity, or some other physical driver that may help communicate that x-axis better. But at the moment, having 2 different timescales helps communicate the uncertainty of timing when, but does still provide the why the trigger could be. So when we look moving along from the current situation with our monitoring and a response to particular hazards or consequences, we're seeing that there's a flag with a triangle. We're getting some early signals through that monitoring and investigation. We get to a trigger, a decision point that the current situation is something we can't progress with. And we've got these 4 possible actions that we might want to consider. Action A provides a pathway that takes us through to the very end. Action B can provide us with a short-term response, but at that period before we get to some critical adaptation threshold, we know with action B we have to change to a different action, either A, C, or D. Similarly, for action C, that can take us some of the way there. It might be good enough for the low end scenario, but still some possible transitional change if the high end scenarios occur. And action D, also similar to action A, takes us through to the high end. When we get to action B, we can see that there's some modification or variation of actions. That may be a combination of actions B and C that could be considered. So at the moment, I'm keeping it high level in terms of I'm not being specific for actions. But what this clearly shows is we've got a tool that can map out the period of interest. And James talked about sort of at least 100 years from the New Zealand Coastal Policy Statement. For urban development, we might be wanting to talk about more 100 to 200 years, so these longer time frames. But then we can see where specific actions and approaches can fit in and provide a response and an adaptation response in a particular time scale. So this slide taken from Judy Lawrence's paper is pretty informative, and it's just a little bit more of a schematic showing our sea level rise scenarios that we have, and we've got the 2.6 to 8.5 and the potential rise of sea level with the uncertainty bands. And we've got some signals, some triggers, some adaptive thresholds where that there's the significant issues if we progress on that pathway, and a change to performance threshold. I just want to pick up on a point that James made in that little really useful plot from Rob Bell showing that change in sea level rise and the significant change in return period. The reason why that is there's actually very little difference in elevation of storm surge from, say, a 10-year event to a 100-year event. often it's in the order of several centimetres to less than 10 centimetres around New Zealand. So sea level rise really has a huge consequence on those, the changing return period of events, because we've got so little difference. So a 10-year storm, quite similar to a 100-year storm. And that's why when we're doing hazard assessments, it's really great to consider a range of hazards and not just pick, say, a 100-year event without understanding the context that a 10-year may actually be very similar. So that kind of flooding impact may be more frequent even now than the communities or decision makers currently understand. So what we have in this figure here, so we've got current scenarios. So we've got 3 little images on the right-hand side. So if you look at B, where we've got development near the coast, we've got a beach, and we've got storms coming. With sea level rise, we're going to get slightly higher storm water. There's probably a little bit more beach erosion. Monitoring can show there's some change in impacts. And there's a threshold or a trigger point here where we've got erosion, say that's approaching a point where some action and decision needs to be made before we get to the threshold where that development could fall into the sea. So when we move along the pathway, we've got a response possibly of building a seawall at the back of the beach, still allowing the beach to function. That seawall with increasing sea levels will eventually get either undermined by storms or overtopped by wave action. So there's, again, another threshold where that design structure exceeds its design limits, and then another adaptation pathway needs to be developed. And pathway B is relocating or transfer of assets away from the hazard, so avoiding risk through retreat. So, and both pathways are possible. So you could go through the development pathway for the midterm or the short term, but with the long-term view providing that managed retreat. Now, with developing these different pathways, it's also important to look at that time context. So yeah, context is everything, both the physical processes, but also the time period that you're considering, to understand where particular actions can come in, but also to allow, say, your pathway B scenario, pathway B approach will take policy change, planning changes, district plan rules, or different planning principles to put those kind of planning responses into effect. And maybe in the short term, there's a physical action that needs to be done to hold the line while the planning and policy rules for retreat can be put into effect and do that transitional change. So often with DAP kind of processes, both the short, medium and long-term process starts at the same time, but may not all manifest at the same time. But what you don't want is having a plan change or a pathway change which your rules and policies don't support. So that brings us through to the Clifton to Tangoia coastal strategy. This was a significant piece of work done by the Hawke's Bay councils and the community. And I was well, privileged really to be part of the team as a coastal expert and working on adaptation responses. I think this was a well-led community effort with significant input and resources, both from mana whenua and the councils, to develop a vision and then put that vision into effect. So the vision was that coastal communities, businesses and critical infrastructure from Tangoia to Clifton are resilient to the effects of coastal hazard. Now this doesn't say protected from, it is just resilient, and it is communities, businesses and critical infrastructure. So that framing, I think, is really important in terms of developing a good outcome. And the reason for that is if you're looking at, say, communities, if you dive down to a single lot, the approach of adaptive policy pathways, when you go down to lot level, is complicated and leads almost to a whole of line mindset, where if you're looking at what a resilient community has, you have a broader discussion on what resilience looks like to that community, and then how do you deal with those more disadvantaged within any policy approach. So within the Hawke's Bay study, this came through from the hazard assessment approach, so understanding the physical hazards and how those change over the time, provided useful context to enable understanding of potential physical change and therefore what could or couldn't work in terms of planning or physical responses. Then what we look at is what matters most. So trying to understand the values and objectives. And within the Hawke's Bay, this was looking at, I guess, across the four well-beings, recognizing population, economic, social, cultural, and environmental all matter and all need to be considered. This is a little bit different from traditional Western approaches, where it's typically the financial and economic loss of infrastructure and assets, and population is typically age and type of population. And it's more aligning to the Te Ao worldview from the Maori perspective, where protecting the environment and the values from that environment means that you can sustain communities and thrive. Whereas if you focus on purely solely on infrastructure and people, you can miss out on some of those values that and environments that are actually important for sustaining communities. The approach also considered each of the four well-beings separately. So we didn't try and equate financial cost to cultural matters or society, but we framed them up so they provided a representation of risk across the four well-beings on an equal way. And certainly the NCCRA sort of also focusing on the full well-being really provided some good ideas of understanding that what matters most varies on the different contexts that you look at. It also recognizes, I guess, in the future, what's important for communities is probably still going to be what's important now. So those values are what brings people to that particular location and setting needs to be understood and considered in terms of designing solutions. Oop. Sorry, I just realized I've been talking to my slides, but not showing you the ones on screen. My apologies. So I'll whiz through these, but this is the risk assessment wheel from MFE guidance, which shows the 10 stages. So what is happening being the first, and showing the risk assessments from the Hawke's Bay, considering climate change, inundation and erosion. What matters most, looking at the values and objectives and the vulnerability and the risk across the four well-beings. So the Hawke's Bay, 22 kilometres from Clifton to Tangoyo, coastal edge broken down into cells and units so we could compare the values and prioritise areas for risk, and much like James was saying, sort of focusing on those with higher risks. And the plot at the bottom showing the inundation impacts as an example, and the changing risk for human, economic, social, cultural, and environmental and ecological risks. So this was used and communicated with the stakeholders and communities to determine areas where we start with the adaptation responses. Then came the question of what can we do about it? So looking at those identification of options and evaluating the options. This also was a very inclusive and open process. So all options were on the table, and there was a lot of community discussion and a lot of Google searches with, can we try this option or that option? Hey, well, we found this, why don't you do that? And what that did is give airtime to every conceivable option and allowed information to be provided back on the pros and cons, or the risks and uncertainty with some of the options available. And the assessment panels, which were developed from the community and interest groups, defined and refined these options throughout the workshop. And the community groups were included a whole range of different views. So we had, so for the Homewana situation, we had people outside or on the landward fringe of the settlement, as well as the Walk on Water advocates for seawalls along Homewana, involved in developing options. And the important thing here was it needed to be inclusive, and consensus was required to develop options and to carry options through. People like myself from the technical advisory group, we were there to provide information and clarification of details, and to help them understand the issues and the risks. And an example on the screen here is a summary sheet that helped communicate the selected options for a particular coastal setting, and this particular one, the southern cell, for the Taowonga section, and looking at options. So the erosion mitigation, and so this was for renourishment with gravel as one of the options, and it was looking through what it did in terms of the short and medium term, and key issues for both positive and negative. So this was developed for all of the different options, and for all of the different kinds of adaptation response. And when it gets to the next phase, so you've got the options and you've identified some approaches. It's working out how those options can perform over what time period, and when the adaptation threshold could be reached, and then what a particular response is for changing adaptation. So these phases for items 7 to 10 on the trigger, looking at the planning and further engagement and development, and clearly articulating the dynamic adaptive policy pathway, defining the signals and triggers to avoid adaptation thresholds, obviously ongoing monitoring and tracking, and which is why thresholds that are based on either outcomes that are unwanted. For example, if flooding occurs every now and again, that may be okay and doesn't hit a threshold, but if flooding or damage occurs on an annual or regular basis where the costs are getting high or affecting the communities, that's maybe when the adaptation threshold could occur. And then phase 5 is when you do review the trigger and action, that there's a reset on the future dynamic adaptation pathway to see if that you're still on the right track. So here's an example, or two examples really, of it in action in the Hawke's Bay. The left takes us through the dynamic adaptive policy pathway approach from a seawall through to managed retreat, and the different timescales there on the bottom, along with sea level rise set for the RCP 8.5 scenario. And actually just focusing on the new IPCC report, that even though the change to SSP, they're keeping a similar number. So the 8.5, 4.5 and 2.6, there's a few more scenarios, and they aren't identical but similar. And certainly from the sea level rise information that we've looked at the moment, certainly for the next 20 to 60 years, there's very little change with the change to SSP. It's in the order of 2 to 5 centimeters. It does increase sea level rise because warming does increase towards 2100 and the order of 5 to 10 centimeters. So there is a change, but certainly using the existing RCPs is fine for planning at this period of time. And when we took the dynamic adaptive policy pathway to the communities, we did find that the metro thing was confusing to many parts of the community. So what we communicated was a much shorter agreed dynamic policy pathway on a page. So this shows for the southern cell in this particular area, in the short term, there was renourishment, and then moved to managed retreat in the medium to long term. And these were developed for each of the coastal cells that we were looking at. And this gives us the final outcome for the communities back in 2017. This was the agreed strategies for each of the priority areas, which tended to be the southernmost parts of the Hawke's Bay cell, down near Cape Kidnappers and immediately north of Metro Napier area. Now, this was done in 2017, and there has been challenges in making progress. And Hawke's Bay and MFE have put out a report that looks at the challenges and what the issues are. And on the left-hand side here is the responsibilities for who does adaptation is ambiguous. And so who takes control once you've agreed a strategy, who leads it and who funds it. The tools and mechanism to manage current and future hazards are limited or inefficient. And there was a lack of agreed approach and principles for sharing costs of the work. So those were three challenges that really have been preventing further progress on implementing the adaptation plans for Clifton to Tangoia up until very recently. And the headline here on the right-hand side is the Hawke's Bay Regional Council has shown real leadership in agreeing that they're going to take the next stage of this work through. So finally, some takeaways for the designers and engineers. It's really important to understand the physical context and the predicted changes over the long term. It's not appropriate just to consider the next 2 to 20 years without understanding the longer term consequence and where those changes that may happen in the shorter term could occur. There has to be clear understanding of the risk and focus on addressing the higher risks, as James pointed out, and that's a practical and pragmatic approach of dealing with the higher risks and designing for each time horizon. So when we're doing a design, effectively there's 3 different designs because you've got 3 different design conditions that you're trying to work with. And through that process, working how you could transition from one design to the other over those time horizons provides you with an approach that can fit along the dynamic adaptive policy pathway. So through that process, is the foundation strong enough? Can you build on it? Is it a rebuild, or what kind of adjustments that you do from your short-term design to get to a medium or long-term, or is it a whole new structure, or is it managed retreat? And considering asset relocation and nature-based solutions are 2 really important concepts that we really can't hold the line everywhere and for everyone. Auckland alone, we're doing a shoreline adaptation plan, 3,200 kilometres of coast. There's going to be the need to relocate key assets and communities away from the more high-risk areas. And for those who may have seen the recent international guideline on natural and nature-based solutions, strongly aligned actually with the RMA and the NZCPS kind of principles of reinforcing natural systems and buffers. Those are increasingly important from an ecosystem benefit approach from mana whenua desires and increasing the amenity for communities. It's important to test the designs for a range of RCP scenarios to see what their behaviour is in terms of the design and understand and communicate residual risks from any of the design options. And finally, what is the trigger for change from one adaptation response to the other? So that is a quick canter through, and apologies for the lag in the slides. I'll now hand back to Monique, who's going to take us through the breakout space, I think.
Kia ora, Richard. Thank you to both you and James for sharing your insights. Before we go into the breakout sessions, because obviously we can't divide the two of you across all of our breakout rooms, we do have a couple of questions from the wider group, which I'll make some room for. Now, I'm just scrolling through to see if I can find any or all of them in any semblance of order. So the first one that I'm seeing here, Richard, this was with regards to your presentation. In the purple scenario, and I should know what that refers to, I hope that you can think through what the purple scenario is, but the comment is that there's a small returning to normal sea levels. Was that on purpose? And commenting that they've not seen that before.
I think that was Richard on slide 28.
That's the performance threshold rather than returning to normal. So if we go back to that slide, so what this shows in terms of performance as you do your adaptation response, the performance threshold when a change comes in. So for example, if we move to pathway B, even though we've had the climate change and sea level rise, the performance improves and comes down to this level. So we're able to deal with the higher sea levels.
I was referring to the lowest band, which is purple, and it shows from around 2120, 2140, the sea level goes down back to what we have now.
Yeah, so this comes from Judy Lawrence, but what the bottom axis goes to 2200.
Yep.
And there's potential that you could get a reduction in sea levels based on the modelling over time.
Cool.
But I guess most focus tends to be on, well, it's still above present day, but there is a reduction if we can. So what that is the very lowest bound of RCP 2.6. If we totally remove carbon, totally remove methane, we could get some restoration back towards the 2000 condition.
And is that in that reference? Because I've been scrolling through it and I cannot find it.
I took the figure from that reference.
Yep. Okay.
They may not have delved into the physical science, so it may be just the figure.
Yeah. Thanks.
Thanks, Richard. I might lift it up. It's great to get into the detail, but before we move on from the DAPT approach, obviously this example and DAPT as a concept more broadly is a community place-based approach. For the engineers on the call who are perhaps working at a different scale than at the community or cityscape, are there elements of the DAPT that you would recommend them focusing on? Say, for example, if they're designing kind of a MEC-Eng type project, or thinking more of perhaps individual assets. Are there some tips that you could almost help downscale from the DAPT approach?
So I think, yes, context is everything. So understanding that short to medium, long term and change and how that fits into your design is important. So I mean, a simple example on a building on a low-lying edge of an urban setting, the floor levels currently may be okay, but those floor levels, so if you're doing a retrofit for a building, for example, the existing floor levels were fine when it was designed in the 80s, but won't be sensible or will get a risk of inundation for future scenarios. So there's a couple of different adaptation responses for that building that may be waterproofing to make it more resilient to flooding when you're doing the refit. If there's sufficient headroom on the ground floor, Do you have the ability to put an overlay on the floor to raise the floor levels and waterproof to get above that floor level? So there's still adaptation responses at a individual scale, but understanding where that fits in on the community and the the longer term setting helps communicate. For example, if you could raise floors, how much time does that buy, and allow people to make investment decisions and pragmatic decisions like that.
Thanks, Richard. James, I'm going to circle back to you with two questions. I'll do a bit of a twofer. The first, again, we'll keep it at sort of the high level. You mentioned that many councils are beginning to propagate a risk-based approach to understanding climate risk that mirrors the NCCRA, and indeed that's being supported by MFE's guidance. For, again, thinking about projects that are perhaps on a smaller scale and maybe not even just necessarily built environment, are there other sources of information that you would point those on the call today towards that would help them undertake their own risk assessment? I've got a part two, but I'll let you answer that more generally first.
Yeah, good question. So in the first instance, at a broad level, the national climate projections aren't too bad for those general climate drivers in terms of, say, temperature change or the broader issues that might be playing out sort of around the different areas or regions of New Zealand. A number of, or indeed most regions now have done some downscaling for their regions. So they've got some downscaled climate projections, which will give more direct or more nuanced and downscaled information on a range of climate variables. The most relevant ones, however, I think, in terms of geospatial, if you're thinking about locations, are going to be your flood hazard information, your inputs into the floodplains that you model and you use to. And one of our observations recently is we've been doing a few, what are they called? Climate adaptation plan credits for the Green Building Council. So they've got one of these credits, and then when you go and actually look at what a lot of the designs are using, they're referencing local council design standards that don't use HERDs. They don't look at a range of RCPs or indeed consider an appropriately conservative time horizon and RCP scenario in relation to the design element that you're looking at. So if you're talking about citing where the building itself goes and the floor levels, then my argument would be you want to be quite cautious and use a longer term, say, that building's going to be there for 100 years, or its floor level will be very costly to change. So for that instance, you might want to use a more conservative and a higher RCP scenario versus, say, sizing the downpipes on the side of the building that you can replace, over time and adapt easily. So I think, that's some of our observations, that there's inconsistencies in what's being used and the need to take a contextual specific approach. So the data on flooding and rainfall is available through HERDs, and then you've got the coastal inundation and coastal erosion layers that some councils have. There's some national layers as well, so it does vary by area.